If we're going to graph g of x, we need to do same things. Find the zeros, find the asymptotes. So 0 is going to happen when the numerator, 2x plus 1, is equal to 0. Solving that, x equals negative 1/2, and that's where our x-intercept is going to be. For the domain and the vertical asymptote, we take the denominator and let that equal 0, so x minus 2 is equal to 0. So x equals 0. As far as the domain is concerned, the denominator cannot equal 0, so x cannot equal 0. When it comes to the vertical asymptote, then, that's the vertical line with the equation x does equal 0. Finally, for the horizontal asymptote, we find the limit as x approaches infinity. And in doing so, we really just simplify this fraction. It's going to be the same as the limit as x approaches infinity of 2x over x. Well, the x's cancel, and that limit will be 2, meaning our horizontal asymptote is the horizontal line, y equals 2. Now let's put it all together onto a graph. First of all, the 0 is at negative 1/2. So I find negative 1/2, and that's where the function will equal 0. The vertical asymptote is at 2. So we use that vertical dotted line. The horizontal line is going to be at y equals 2. So if I go up 2 and draw a horizontal line, that's where that asymptote will be. Now let's go back and identify the sign chart. So picking something extraordinarily negative will make the numerator negative and the denominator negative. So the whole fraction is positive. As we pass over negative 1/2, 2x plus 1 turns positive. So positive divided by negative is negative. Finally, if we pick something very positive, the numerator is positive and the denominator is positive, so this fraction will be positive. So let's put it all together into a graph. On the left interval, it's going to start at 0 and go up to the asymptote. So this is what this branch will look like. In the middle interval, it's going to stay at that 0 and then become negative, so go below the x-axis over to the other asymptote. And finally, on the right interval, it's got to be positive and get closer to both asymptotes, so that's what that branch looks like. And there's a graph of g of x.